Compute simple probability. And when we're using simple probability, we're talking about using totals. So the entire piece of what we have. We're not doing anything fancy, just using totals. So the probability, let's talk about what does that mean. Well, the probability is the likelihood of something happening. So when we talk probability, it must be between 0 and 1 inclusive. If we have a probability of 0, it means it cannot happen. So when they say there is a 0% chance of rain, it cannot rain. 0 means it's not possible for that to happen right now. If we have a probability of 1, it means it definitely will happen. So I always like to do this when I was teaching. I would ask my students, what's the probability of us having homework tonight? And they'd be like, 1. And I'm like, absolutely, because it definitely was going to happen. Normally, it's somewhere, the probability is usually greater than 0, but less than 1, right? We'd say maybe a 50% chance or an 80% chance. So we can write probability as a percent, as a decimal, or as a fraction. So it really depends on what we're talking about how we write it. So let's jump into what does this look like and how do we find it? Right? So there's some formal definitions, but the basic idea of probability is what we want over the total number of possibilities. This is the basic breakdown of probability. So when you're like, if I'm rolling a die, what's the probability of rolling a 2? Well, what do I want to happen? I want a 2. So how many times can that happen, right? So the number of times that's possible for what I want to actually happen over all the possibilities. That's the basic premise of probability. So you'll notice that we write it naturally as a fraction. So if you want it as a decimal or a percent, you've got to change it from there. So let's jump in. Let's look at some examples. You have a bag of 50 marbles. This example brings me back to my childhood. We used to play marbles at my grandma's. So loud, everybody, well, the adults hated it. We loved it. Anyway, back to the problem. We've got 18 blue marbles, 11 red, 6 green, 7 orange, and 8 yellow. If you pick a marble at random, what is the probability it is orange? Okay, so we're looking at, we want orange, and that's going to be over the total number of marbles. So think about this as a fraction. How many orange marbles do we have? Well, the problem says 7 are orange. Okay, well, how many total marbles? Well, the bag had 50 in it. Okay, so that means we have 50 marbles. So as a fraction, my answer is 7 over 50. If you want that as a decimal, it's 0.14. Or we could say 14% of the bag is orange marbles, right? But this is the probability that I will choose randomly an orange marble. Let's do another one. You have a bag of candies with 6 pink, 4 blue, 3 purple, and 5 green. What is the probability of randomly choosing a candy and finding it to be blue? So now we want a blue candy over the total. Okay, so this starts easy. How many blues do we have? Well, it said there are 4 blue. So my numerator is 4. Now, how many totals do we have? Well, they don't give us the total. We're going to have to find this. So we have 6 pink plus 4 blue plus 3 purple, plus 5 green. So 6 plus 4 plus 3 plus 5. Well, that gives me 18 for a total. So I'm going to have 4 over 18. Now, mathematically, we don't ever leave a fraction unsimplified. So those are both even, so we can reduce by 2. So we could say 2/9. As a fraction, if you want to change that to a decimal, it does not come out nicely, but we could round it to 3 places and have 0.222, right? So roughly 22% of the candies in this bag are blue. And that is simple probabilities using the totals.